With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is if the vapor pressure of a dilute solution of glucose is 750 millimeters of mercury at 373 Kelvin, then the molality of the solute is. So in this question, it is given that the vapor pressure of dilute solution is given of glucose is 750 millimeters of mercury and the molality of solute we have to calculate. So first of all, we have given the vapor pressure of the aqueous solution, that is 750 millimeters of mercury, and it is given aqueous solution. So aqueous solution, it means the solvent will be water, and for this the water has the pure water has the pressure as 1 atmosphere, that is equals to 760 millimeters of mercury. Now we have to calculate the molality of the solute. So molality is calculated as molality is equal to number of moles of solute divided by mass of the solvent into 1000. So this is how the molality is calculated. It means we can write it as number of moles of solute, write it as NB, and the mass of solvent, let it as, let the solvent be A and solute be B. So mass of solvent would be WA. If we multiply and divide it by its molecular weight, so we will get, this will be the number of moles of solvent, WA by MA, that is given weight upon molecular weight. So we will have NB upon NA into MA, that is molecular mass of solvent into 1000. So we can calculate the molality by this formula. Now we want the number of moles of solute and number of moles of solvent. So we can calculate this by firstly the relative lowering in vapor pressure. So that will be P naught A minus PS divided by P naught A, that is equal to mole fraction of the solute, that is XB. This is equals to, this is the relative lowering in vapor pressure. Now the pure solvent has vapor pressure, that is 760 millimeters of mercury, and the solution has pressure 750 millimeters of mercury divided by 760, which is equals to the mole fraction. Now this gives us 10 divided by 760, that is 1 by 76, which is equals to 0.0132. So this is the mole fraction of the solute. Now if we have the mole fraction of solute, so we can calculate the mole fraction of solvent. So that would be, because mole fraction of solute plus mole fraction of solvent, that is always equal to 1. So we have XB plus XA equals to 1. So we can find out XA, that is equals to 1 minus XB, that is 1 minus 0.0132, which will be equals to 0.9868. Now to calculate molality, we require the number of moles of solvent and number of moles of solute, but we have the mole fractions. So if we write the mole fraction of solute, that would be number of moles of solute divided by the total number of moles, and the mole fraction of solvent will be number of moles of solvent divided by total number of moles. So if we divide this will get cancelled. It means XB upon XA will be equals to NB by NA, that is mole fraction of solute upon mole fraction of solvent will be equals to number of moles of solute upon number of moles of solvent. Now this ratio, it will be equals to 0.0132 divided by 0.9868. This values of the mole fractions. So now we can put these values, that is NB by NA, in molality formula to calculate the molarity. Now Ma is the mass of solvent, so solvent is water and the molecular weight of solvent is, that is water, is 18 grams. So molality will be equal to NB divided by Na into molecular weight of solvent into 1000. So this ratio is 0.0132 divided by 0.9868 into 1000 divided by 18 gram, that is molecular weight of water. So this is equals to 0.743. So molality is 0.743 mole per kg or 0.743 molar. So the correct answer to this question is C option, that is 0.74. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.